In this box, there is one of the greatest secrets of World War II. In the early days of radar, we were unable to develop high enough powers with the standard valves then available to use the wavelengths in the microwave region. We couldn't develop the power. You needed kilowatts of power to produce a radio image of the ground or to spot U-boats on the surface of the Atlantic. And I'm pleased to say that in November 1939, John Randall and Harry Boot managed that feat. Working in Birmingham University with the very basic equipment, they managed to cobble this device here, which was called then, and still is, known as the cavity magnetron. So it comes in its own little wooden box, probably quite a valuable piece of technology. And what you have is a very, very powerful valve, specially made and very secret, because it utilised a new technology known as the resonant cavity magnetron. And inside this large, heavy brass cooling fins, there sits in there is a copper block, which is known as an anode. It's got various cavities bored round inside with little flute holes, and in the centre is a filament, as you can see, with the glass envelope coming out there to supply the insulation. You have the rather strong filament wires coming out, and the filament on this particular example is still intact. It uses 5.3 volts at about 2.3 amps, or maybe slightly more if you wanted to slightly overrun him. But what happens in the central filament, the electrons fly off, and with the aid of a couple of magnets mounted either side of the magnetron, the electrons are caused to fly around. Obviously, you have to apply a little bit high tension to the cathode and the anode there, and you get an effect a bit like a cyclotron effect. The electrons inside will whirl round in the magnetic field according to the right hand rule, so they will be doing this, and whilst they're passing through the cavities which are bored in the solid block of copper, they will create a note, a bit like a penny whistle if you like, only this is not done by wind, it's done with electrons, and it causes the electrons will cause in the gigahertz wave band, which is extremely clever, but it also does it at a very, very high power. And this enabled the cavity magnetron, when flown in aircraft, it would enable for the first time a radar device to spot U-boats on the surface just by the periscope alone, because obviously because of the fine wave, because of the very, very high frequency and small wave band, you have more chance of detecting a small object with better definition. This particular device here is designed to produce 3 centimetre wavelength, which is very small, requires a very small aerial, and consequently the radar equipment is very portable. As I say, the British invented it, Randall and Boot. Totally new. The Germans have nothing like it. The Americans, when they saw this, delivered to them on the Tizard mission, one of our greatest secrets that we wanted to share with the Americans, and they couldn't believe it until it was demonstrated to them. And when they had a look at the x-rays, they could see how this thing worked. So it's beautifully made. It's got the glass envelopes, it's in the insulation at the end there, but very dangerous to be in the proximity of it when it's in operation, because obviously it produces about 10 kilowatts, and the high tension required to produce that is in the order of 27 kV at about 30 amps. So obviously there would be a lot of activity, and I've actually tried running the filament. run it from a DC transformer, and the actual copper block will actually get hot despite the fins. So awful lot of available power. Again, it was a British invention. Made by, this particular example was made by GEC, which was a British company, a General Electric company, and it's got the wartime arrows, then the CB1482, which means it's a 3 centimeter magnetron. Very, very heavy. Biggest problem they had with it was it was so secret they didn't want to put it in planes, because they discovered very quickly after Halifax crashed in testing that the copper block and the actual device itself would survive an explosion. So it was a bit like the old black box, always survives an air crash. They tried to destruct devices, but it would just blow it out the aircraft, and the Germans would still be able to reconstruct what it actually was. And it was only very late in the war that the Germans actually did capture examples, but it was too late for them to do anything really with it, really, because they had already lost the war. But I thought you would like to see it. Absolutely fascinating piece of kit, very, very heavy and solid. As I say, we certainly knew how to do it then, didn't we? And it was thanks to a couple of scientists in Birmingham University that we actually, with this you could bomb through cloud and in darkness, spot U-boats. So we won the Battle of the Atlantic with this, and we also were able to bomb the German targets. And obviously with the European weather, lots of rain, lots of cloud, bad weather generally, this enabled the bomber force to go out later on in the war in 43, 44 to see the targets in complete darkness. So say the Germans didn't know what hit them. They had nothing like it. And hope you enjoyed this video. It's a superb bit of history there. Delighted to share it with you. Thank you.